So a function is like a machine. Say we have y equals negative 2x squared plus 7. And jump right to a big one here because we're short on time. Okay, this is an equation you've seen before. If I were to change it to this is actually function notation. And this basically means the function f, where x is the input, okay? And f of x is a fancy notation for y. You're not going to do anything with f of x, means the same as y. What the function does is it puts an x value in, it applies the rule, and spits out f of x, or y. Okay. If they give you a domain, -1, 2, 3, for instance, then we're going to put that into a table and evaluate each one separately. Okay, now the book shows you 3 columns. They actually put the rule here and do the work, and then they put the f of x. I don't like that because then when you're done, basically your x and y are separated, and if you wanted to graph them as an ordered pair, you'd have to eliminate all the junk in the middle. So I would recommend you do the work over to the side. So when we plug in -1, we're going to do -2. You're going to use parentheses. Okay, and we follow order of operations. Whenever you have a variable squared and a coefficient in front of it, and then you're adding and subtracting something else, it's kind of like the at symbol. That's how I like to think of it. Because we have to do this first, then we multiply by -2, then we add or subtract whatever comes after. So what we really have is -1 squared is 1, right? And -2 times 1 is -2, but we still have to add 7. So that would be 5. If you do this wrong, some of you are going to go, oh, -2 times -1 is 2, and then I'm going to square it. 2 squared is 4. 4 and 7 is not 5. Okay, following order of operations is very important here. You're going to get some weird outputs. So that would be 5. Then we do -2 times 2 squared plus 7. So we do that first. So this would be 4. -2 times 4 is -8. Plus 7 is -1. And then -2 times 3 squared plus 7. 3 squared is 9. So that would be -18 plus 7, or -11. I would recommend that you do these in your head, because all it takes is one slip up or one wrong way of inputting it into your calculator, and you've got a completely wrong answer. You have more control over it when you do it one little step at a time. Okay? And this is going to become very critical further down the road in geometry, well, in algebra. When you get to quadratics and you're dealing with x squared in every problem, you want to make sure you're following that order of operations to the T. Okay? And more people, like when they do it on paper and not the calculator, unless you don't know what a number squared is, You know, unless you're just checking your multiplication in your head. I would do it on paper so you're in control of the signs and everything else. Right? Okay, so I know this isn't, I would have given you a couple more functions to look at. On the website, there are notes attached that have a couple more examples. Okay? And I'm trying it out, but since there's a lot of videos out there of people explaining this stuff, I'm attaching extra videos on the website, so you can, I'll try and get mine on there, and give you another one.